Hello, Biswaru. Hi. A very good evening to you, and thank you for joining in. Hi. We'll start at 7:35. Okay, 7:35. Hello. Sure, Biswaru. We'll discuss the new project first. Okay, no worries. Actually, you're the only one here. Can I unmute you? Can I unmute you, Biswaru? If it is okay for you. I wanted to discuss. I want to take your feedback as well. Ma'am, okay, your mic is. No worries. Okay. How is the current module going on? Are you able to understand fundamentals of NLP, transformers, LSTM, RNN, all of that? Are you able to understand a little bit what is transformer fundamentals? Yes. What we have been doing in the class, and are you solving the questions as well? Are you finding the questions interesting, or you did not get the chance to take a look at the questions? Okay. Okay. Mr. Rup, it would be great if you could take out some time and solve some questions because they will actually help you in cementing the learnings. Okay, is it okay if I call you Biswa? Is it okay? Cool. We'll wait for one more minute and then we'll get started. Actually, I also have a friend whose name is Biswaru, so we call him Biswa. I'm sure that most of your friends also call you Biswa, right? Yeah. That is easy. That is easy to pronounce, right? Great. Okay, we will start. Have you solved this was the last one, Flip It News? The last one, have you solved that business case study? Okay. ठीक है. I'm afraid you're the only one present here. Should we continue or shall we reschedule this session? Okay, we'll wait for one more minute, 7:36, and then we'll get started. If someone joins, we'll take it. Uh, Probably yes, Visurup. The project must be live. I'll have to check that. I think it is live. Can you go ahead and check on your dashboard on the all projects list if you have Twitter NER live there? Because I'll have to ask someone if it is live, yes or no. It will become easy for you. Okay, just give me 1 second. Let me do it. 1 second. I'll do it. No worries. Yes, it is live. It is live. It is live. It is there. It is live. Okay, it is live. Cool. So everything is there except for the dataset link. Okay, give me 1 second. Let me add the link here. Biswar, can you confirm if you can access this link that I'm currently sharing? Okay, this is not getting pinned. Is this accessible? Is this link? Drive folder where you have two files, both are co-NNL files. One is the train dataset and another one is the, okay, you're able to access, right? So you have these two text files, these two text files. This is my train dataset and this is my test dataset. Okay. You have to combine these two to find your total dataset. Okay. Great. Hello, Pranav. Hello. Hello. Hi. 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 Cool. Shall we start? It is almost 7:37. We will first go through the intro part and then we'll take the review. Okay. Hi. Hi. So here, in this business case, till which lecture have we completed in the live lectures? Transformers is done, LSTM is done, RNN is done, right? Yes or no? Which lectures have we completed so far? Today is May, so we have also completed attention. We have also completed transformers as well. Very good. Okay, the only lecture that is left is BERT. BERT is left, right? BERT. Cool, cool. So in today's lecture, we are going to discuss two things. One is the introduction of a new business case study, which is dependent upon NER. NER is nothing but named entity recognition. Named entity recognition. How many of you remember? Do both of you remember the class NER we had on May of 8th? NER, named entity recognition. It is just an application, a good application. Okay. Yes, just like part of speech tagging, absolutely correct, just like pause. But this is a little more advanced, a little more advanced. This with more context, absolutely correct, absolutely correct. So here, okay, let's go one by one. Okay, this data set that we have shared is of Twitter, and Twitter is a microblogging website and a social networking service, okay, on which users they post and interact with the messages, and those messages are known as tweets. So whatever you want to say, you can say on Twitter, and the people who follow you, they will comment on it, and you can basically express your opinions on Twitter. Okay, every second, on an average, around 6,000 tweets are tweeted on Twitter, corresponding to around 3.5 thousand tweets sent per minute, and around 5,500 million tweets per day. Okay, every Twitter, for example, you are working as a data scientist, always think about yourself in that shoe. Okay, always think that you are a data scientist and you want to automatically tag and analyze tweets for better understanding of trends and topics without being dependent on the hashtag. So there are two things. Okay, do you remember in the Twitters we have those hashtags, right? Hashtag something, hashtag let's say currently today, hashtag Karnataka elections, hashtag UP elections, something like that. And then there is a on the right hand side you have hashtag me too. Yes. So on the right hand side you have trending button, right? Which hashtag is trending on a particular day or in a particular hour or at a particular location. So that actually tells us, okay, this is the topic which is famous or which is in the trend at this moment. But imagine you are a natural language expert, okay, uh, and you want to not depend upon these hashtags. On the other hand, you want to depend on the data that you're getting from the context, from the text that people are writing as tweet. Okay, what does this mean? This means you are going one step further into your analysis. You are not just dependent on hashtag Karnataka elections, hashtag me too. You are analyzing the text to understand what topic is more important, what location is more important. And then you can refer or you can say that, okay, this at this position, at this location, this is the trend, something like this. Okay. Now imagine if a person is sitting in London. Okay. Imagine a person is sitting in London and he is talking about Karnataka elections at this moment. Now, generally, what Twitter will try to find out its location. Okay, do you remember this? Is there is a pop up every time you use Chrome or any website that they ask you for your location. So on those dashboards, on his dashboard, he will see only the hashtags pertaining to him for that location, London, what is most famous in London. But he is talking about Karnataka elections, right? So how do I create the independence between the two? Can I show him that the topic, the text that he has written, I want to show more and more tweets related to those. Okay, I want to recommend book. So what I want to do here is I have a text data. I want to analyze that text data, and then using that text data, I want to finally create some tags. Create some tags. So, for example, if he's talking about Karnataka, I can say, okay, this is the topic which is hot at this moment. Okay, there is another topic. Let's say he's talking about some elections. So I can talk, okay, this is the more important topic at this moment, election. But he is sitting in London, he will be able to see the trending topics in India as well, because he has those attributes somewhere in his tweets. Okay, so many users do not use hashtags and sometimes use the wrong hashtags. This also takes care of that fact as well. So they want to completely remove this problem, dependency on hashtags, okay, and create a system of recognizing important content in the tweets. Now, how can we solve this problem? There are multiple ways to solve this problem. One of the solution is to use named entity recognition, which is NER. Okay, it is an important subtask of information extraction that seeks to locate and recognize named entities. Named entities. So let me show you. Let me show you. Okay. So if you solve this problem statement, you will get something like this. You will get something like this. One second. Where is that? Okay, it's here probably. Okay, here only. Have you, don't you think this is a much better way of representing? For example, there is a sentence: Zendesk security breach affects Twitter, Tumblr, and Pinterest. So, what is Twitter essentially? Think about it. What is Twitter? Twitter is a company. Do you agree with me that Twitter is a company? If you see here, we have tagged Twitter as a company. Similarly, we have tagged Tumblr as a company, Pinterest as a company, Zendesk is also a company, right? Snapchat is a company. New Year's Eve, it is an event. It is an event. So we have tagged it as other. Today show is a TV show. It is a TV show. What about a location? For example, White House hiding Pentagon report on Russia's breach of nuclear treaty. So what is this Russia? Russia is geolocation. Geolocation means a particular location on geography, right? Similarly, ICANN is a company. Saint Joseph Health is another company. If I am able, think about it, if I'm able, and then there is one more, James J. Emilio Florspick. This is a person. Don't you think if we are able to tag individual words depending upon the type of that word, we will be able to do a uh, one level above the normal level of analysis? Do you agree with me? We are taking one more step in the analysis. We are able to identify each word, and then based on those in words, we'll be able to do much better analysis of our data set, right? So here in this data set, we have 10 fine-grained NER categories. Okay, one is person, geolocation, company, facility, product, music, artist, movie, sports team, TV show, and other. Others, everything else other than these 9 categories. Dataset was extracted from tweets and it is structured in a different format that you've not seen before. This format is known as CoNNL CoNLL format. Okay, this is a very popular format for NER, and it contains a text file format. Text file format. So how you have to understand this data set? Okay, let's understand that. So the CoNLL format is a text file with one word per line with sentences separated by empty line. What does this mean? Let's say we have a sentence like this: Harry Potter was a student living in London. What is Harry Potter? What is Harry Potter? Mr. What is Harry Potter? Name, right? This is a name. This is a name. Name of what? Name of a person. Can I say this is name of a person and this is also name of a person, right? So these two are persons. Next, there was a student living in London. What is London? If you have to think about what is London, London is a geolocation, right? It is a location somewhere. So if I'm able to identify these important aspects of this sentence, I'll be able to do better analysis. CoNL helps me achieve that. So the same sentence, Harry Potter was a living student in London, can be written in this format. Okay, in this format, where each line contains only one word of the sentence. So, for example, here Harry Potter was a student living in London. Right? What is Harry Potter? Harry Potter is a person. PER is person. Then again person. This is other, and finally geolocation. Geolocation. Okay. Now, similarly, we have Albus Dumbledore went to Disney World. So, what is Albus Dumbledore? Albus Dumbledore is person. Disney World is a facility. It is a place, right? It is a facility. And went to there are other words. Is the notation clear? How CoNL file is created and how you have to read it? Give me a thumbs up, Biswarup, if you're able to just understand how CoNL file is created and what is the tag. So these are separated by a space. Okay, these are separated by space, and two sentences they're separated by an empty line. Two sentences they're separated by an empty line, and each sentence has one word. Or for example, let's say 10 words. So they will be in 10 individual lines, each word in one line. Each word will be associated with the proper tag. Now you must be thinking, Nikhil, what is this B and what is this I? Is this question coming to your mind? What is B and what is I? Right? Cool. So we'll talk about that. Okay. B and I basically represents starting of the word. No. It represents starting of the word or starting of a sentence. Basically, B represents that this is coming at the start. I represents that it is coming somewhere in between. And sometimes B represents the first one for geolocation. Okay, something like that. But we'll talk about this. Okay, this you can also find on internet. What is this BI? We have explained this in the document as well. Now, how do you have to solve this business case? What is the process? First of all, do you remember LSTM, CRF, conditional and random fields, and long short term memory? Both of these, right? So in this case, what you have to do here is you have to import the dataset, train dataset, and understand the structure of the dataset. We have understood the structure of the dataset. Now all you have to do is import the dataset, and you have to divide between train and test. Currently, we have also given you two datasets. The first one is train, second one is test. Okay. Second, you have to do some exploratory data analysis and checking the structure and characteristics. So you can add them. You can when you download the dataset, you'll be able to understand what is the ratio. You have to add them, and finally, after adding them, you can train your data model on the train dataset, and then you can test it on test. It is separated. If you go here, they are separate, right? This is my training dataset, and this is my testing dataset. So they're already separate, so that you don't have to worry about this. Okay. Next, you have to do some data processing. You have to prepare the data in the format required by the model. Now, this is a step that you have to do. How will you pre-process the data so that it can be fed to the model? This is an important step, and this is the crux of this business case, that how you will convert this co-NLL format data into a data which can be consumed by the model. Okay. Next, you have to train a model, LSTM plus CRF. You can also go ahead with simple LSTM bidirectional models, but it is recommended that you use LSTM with CRF. You can try with different models as well. Okay, whatever you feel is good, you can try that. Then you can use word2vec or glove here. Okay, here it is written use a word2vec model to initialize the embeddings. It is on you. Whatever you feel is better. You can use word2vec or glove or the simple ones, right? Bow and TF-IDF to initialize your embeddings. This is totally on you. Or you can also do something. You can try on multiple embeddings, at which embeddings are giving you better results. That is also on you. Okay. Next, you can train a TensorFlow tokenizer. You have to train a tokenizer for these embeddings. Next, you have to split the data, train and test, and then finally you have to train the model. Okay. Then understand the implications of using bidirectional models. The entire purpose of this business case study is to understand that how bidirectional model works and how they are different from unidirectional. So first do one thing, you create a simple unidirectional model for LSTM, and then do bidirectional. So you'll be able to see the difference. Yes, Biswarup, it is a pre-processing step. Okay. Cool. You'll have to create tokens, right? You'll have to create tokens from the embeddings. Simple. right? All those things, stop words and all of that you can do, right? I'm hoping that you can do. Give me a thumbs up if you're comfortable in removing and pre-processing some all of those steps. Great, great. Next, uh, next is align the labels. Okay, you have to align the labels to input. So, for example, you have to compute. You have to align the labels. You have one word and then you have labels. These are my labels. These are my words. You have to align them. Okay, this is also a pre-processing step. How will you do that? Okay, and then finally compute metrics to show effectiveness of the trained model. You'll have to find out accuracy, F score, and all of those things just to understand the data. Now you have to compare all of this with another model, and that another model is going to be transformer based model. Earlier we did the same process for LSTM plus CRF model. This time import a transformer model. What is the library that I can use to import any transformer based model? What do you write? Import what? Very easy. Transformers, right? Transformers is in itself a module. Transformer is in itself a library, a module. So you can directly import that. Okay. From that library, we have done this on BERT based uncased. Uncased simply means that it is independent of the lowercase and uppercase. You can change this. You can make this cased so that we are able to identify the capital letters or the case. Case means lowercase or uppercase. Uncased means that this model has been trained and it performs very well on what any type of data, whether it is lowercase or uppercase. If you want specifically that lowercase words should be treated differently with respect to the uppercase, you have to use cased in that case. Okay. And then there are two versions of BERT, base, and then there is an advanced version as well. So in this case, you can simply use base. Okay. Now you have to load the model and the model configuration. Get the tokenizer for that model. Okay. Get the tokenizer for the model. Tokenize the data so that it can be fed into this model. Tokenize the data. Okay. Understand what change tokenization you have to do. After tokenizing, check if the data is correct or do we need to add or remove some tokens. Simple. This is a very, very easy step. Okay. And then finally, you have to repeat the same steps. Train the data, train, test, split the data, train the model on this data. Try various hyperparameters here. Various hyperparameters. Try with different number of epochs. Early stopping. How many of you remember early stopping from neural networks module? Yes, Bisaru. All of this we have to do. This is a heavy business case. Okay, this is not a easy business case. You'll have to do all of this. All of this. Pre-processing is very, very simple, right? Very, very simple pre-processing. After that, you have to tokenize the data and all of that. Info may be lost. Okay, consider you don't have to do that. Okay, you can do that, but if you feel that most of the information will be lost, don't do that. Okay, think. There is no one solution to this entire problem. Okay, it depends upon your approach. Whichever scores the best. Yes, whichever scores the best. Absolutely. Okay. Do you remember this early stopping? What is early stopping? If I have to ask you, what is early stopping? What is early stopping? If I create a chart here, what is early stopping? To stop overfitting. Very good. So we stop at a point where the difference, right? Difference starts where this flattens, where this curves flatten. We stop at that epoch so that we are not unnecessarily running the epochs. Okay, we stop early. There are multiple various optimizers. You have to check for metrics. There is one thing that you will observe in this data case, in this business case study, that this is a highly imbalanced data set. Highly imbalanced data set. This data set is highly imbalanced. Now, Viswarup, if I have to ask you, what are the different entropies that you can use? You must have seen binary, cross entropy, and all of that. Do you remember all of that? Give me a thumbs up if you remember. It is not a binary. I'm just saying. You remember all those entropies? So in this case, you'll have to use, okay, this is a hint. You have to use sigmoid focal cross entropy. Okay. Try to search for this sigmoid focal cross entropy. This has been proved that this type of cross entropy works very well on highly imbalanced data. Okay, Viswa? You'll have to make sure that you're using sigmoid for focal cross entropy. You can check for other cross entropies as well. Okay, but this is a suggestion. Try this, you'll get better results. Okay, sigmoid focal, and learn about this. Read about this. What is this sigmoid focal cross entropy? Okay, is this cool? Is this cool with everyone? We have Pranav and Reshma here as well. Is this cool? Great. This is just a suggestion. Okay. Next, align the output. Align the output of each subtoken because we want the result to be subtoken. We have the results for subtoken. We need to combine back into the tokens. Then make some predictions and see if the trained models are working fine, yes or no. Okay. Then finally save the transformer model with model.save pre-trained method and check the results on your own sentences. Write down your own sentences and check the result if it is performing good or this is the case. Okay, and I'm telling you this is not this is not an easy business case study. So if you go here, this is a sample solution that we have created. You will observe that most of the values, they are lying in the other wala part. Okay, they are lying in the other wala part here. So you'll have to somehow remove it. So in the pre-processing also, you will have to remove this, and you will also understand. You'll also get from the data that most of the values are lying in the other tag, that other category. So after removing that, you will observe that this is the distribution of my data. Okay, company, facility, geolocation, movie. Then there are other categories: person, product, sports team, TV show, company, facility, something like this. Okay. Now, what is B and what is I? B is start token for a tag. So Albus Dumbledore. This is a particular tag. Let's say person. So start token for a tag is represented by B. Okay. I is the continuation tag. That's only difference. Okay. So that you can combine those two words and understand that that is the same word. For example, Biswarup WB is attending this lecture. So ideally, Biswarup WB is a single name, right? So B and I for a particular tag. Two words. Then you'll have to do some pre-processing here, and we will perform some LSTM, CRF, and then we'll continue from here. Okay, we'll continue from here, and at the end you will get some result. You will get some results. Okay, you will get some result. Apple MacBook Pro is the best laptop in the world. So Apple currently it has identified that this is a product. MacBook is a product, which is correct. Apple MacBook is a product. If you observe here, this B is the starting of that particular token. This I is the continuation of that tag. Pro is again my product. So Apple MacBook Pro is all the three are product. The first word is represented by B. The continuation of the token is represented by I and I. Okay. Then is other, and all the words are others. So you can try this on your own sentences. You can try this on your own sentences. Is the business case clear? How do you have to solve this? At least you've got the idea. Give me a thumbs up. What steps you need to take? We have three people, Reshma, Pranav, and Biswarup. Is this clear, guys? Tell me. At least the direction in which you have to think. And this is written there on your dashboard as well. Okay? And the dataset link I have provided here. And one thing, just make sure that you're using sigmoid focal cross entropy. Okay? That will give you better results. Just a hint. Okay? Cool. Can we start with the review? This is the introduction about Twitter and NER. Can we start with the review? Give me a thumbs up if we are ready to start. First of all, how many of you have solved this? Reshma, Pranav, and Biswarup, how many of you have solved this? Okay, Pranav has solved this. Reshma and Biswarup. Biswa, have you solved this? Okay, so you have solved this, right? So you have solved this. Okay. No, you have not. Okay, Biswa has solved this. Correct. Do you remember the context, Pranav? The context. This was a very, very easy business case. No complications. NER is a little bit difficult. Here you'll have to write a lot of code. But this was very easy. Okay, this was very, very easy. So the context was that we have Flipit News. Okay, there is a company Flipit News, and they want to revolutionize how we perceive the finance, business, or capital market investments data or information or the news. Okay, using AI and machine learning. So the ideal or the basic thing was that I have some articles, I have some categories, I have to properly classify those articles depending upon the type of data that I have. Okay, that's it. So here the main steps were that I have to import the library, load the data set, data exploration, text pre-processing. Here, this was something that you have to perform. This is our learning. Okay, removing the non-letter words, tokenizing the text, removing stop words, lemmatization, and then finally we had to transform the data. We have to create the embeddings, encoding the target variable. We could use bag of words, TF-IDF, or both, or you have to check. And then we'll create some train test split, and then we'll compare multiple models. Okay, a simple approach is to use knife base. Very, very simple approach is to use knife base. Next, we asked you to create a functionalized code to perform the model, or you can train the model decision tree, nearest neighbors, and random forest for the same data set to understand which performs the best. This was our goal. Okay, so here going step by step, let's go step by step. Okay, let's go step by step. So let me go step by step. So here in the first step, we imported the library. Simple, we imported the library, the required libraries, pandas, numpy, warnings, then matplotlib, seaborn, regular expression as well, NLTK, tokenized. Then we imported NLTK download pump, okay, for tokenization. You can use others as well, no worries there. Then to remove stop words, we will import the stop words. Then we, for word limitizer, we'll use WordNet. We can use other WordNets also. Then for bag of words and TF-IDF, we will import counter vectorizer and TF-IDF vectorizer from scikit-learn. And then to make the categorical encoders, okay, we will use categorical encoders library as CE. Okay. Now here we will try with multiple classifiers, decision tree, k nearest neighbors, multinomial knife base, then random forest classifier, and all of this will come from scikit-learn. Then similarly train test bit. I think this you have done multiple times, right? Then accuracy score, ROC, AUC score, F1 precision score, recall. Then you'll also call confusion matrix and classification report. Okay. Then the next step, how do you load the data set? So we have loaded the data set here. We have loaded the news article. We have separated. So we got something like this. In the first, we have the category, and in the second one, we have the article. Our goal is to understand these articles to correctly label the categories. Okay. So in the data exploration step, what we will do, we will try to first check the shape, our initial data exploratory process, right? So we'll try to find out the shape, and then we will try to understand which is the more popular or most popular category. So technology, business, sports category, entertainment, and politics. We understood that most of them are fairly similar, right? Business and sports have a higher weightage here. After that, politics, then technology, and finally entertainment, but essentially they are more or less same. So if I have this type of data set, should I consider this data set as balanced or imbalanced? Balanced or imbalanced? What happened? Bore ho gaye kya? Balanced, right? They're pretty much balanced, right? Similar data here. So the next step, we will do some text processing. So I just took one article, the first article, and I wanted to understand how I can do the pre-processing so that I can replicate the process for all the data set. So here we are removing the stop words. Okay, here we are tokenizing the data sets. We are removing the non-letter words. Then we are removing stop words. Then we are doing some lemmatization. Here you can also perform stemming. Okay, just to check if it gives better results or not. But generally, lemmatization gives better results. So we have done lemmatization here. Okay. After pre-processing, so we have two sentences here. This sentence is before pre-processing, and this data set or this article after pre-processing. So you can directly observe the difference between the two, pre-processing and after pre-processing. Basically unprocessed and processed data. Okay, then we will convert our these values, technology, business, sports, entertainment, and politics, into ordinal encoder. If you want to read, we have also provided the link here. Basically you will try to encode your categorical features as ordinal. Simple. Okay, ordinal encoding uses single column of integers to represent the class. What does this mean ordinal encoding? What type of chart that you will get? So what is this? If this is 1, 2, 3, 4, 5, if I create an ordinal vector like this, which category it is representing? Which category it is representing? Think about it. Uh, Hello. Hmm. So there are multiple. Okay, there are multiple encoders. Politics, the last one. Very good. Very good. The last one, right? So you can go ahead and check this. I'm going to just paste this link here. If you have any doubt, you can go here and check this. Okay. So this will represent the last one. Okay. Then we will do TF-IDF and bag of words to create our embeddings. To create our embeddings. So we took just one sentence. Okay. You have the option to choose between bag of words and TF-IDF depending upon your choice. You can do whatever embeddings. For example, if you choose bag of words, it will create bag of words. I personally do both. Okay, just to understand which one is giving me better results. So after that, we'll create train test split. Then we will find the shape here. The number of train data set is around 1668 and test data set is around 557. So around 75-25 split. Okay, 75-25 split. Then we will perform a naive based classifier, a simple naive based classifier. We'll test for multinomial naive base. We will train the data nb.fit x train and y train, and we will try to find out the accuracy. Train accuracy comes out to be 98%, which is very high. Test accuracy also comes out to be very high, which is 0.977. We'll try to make some predictions here. We'll try to make some predictions here and calculate the AUC and ROC AUC score. We got the score as 0.99, which is also very, very high. Okay. Then we will try to find out precision recall in F1, same. So 0.977, 0.977, 0.97. These are fairly, very, very high. Okay. So I can say that, okay, knife base is performing very good. A simple knife base is performing very good. Simple knife base. Then we'll create confusion matrix here. For confusion matrix, we observed that most of the data are actually lying in the correct category. So if you observe here, 98, 124, 128, 92, 102. So is this performing good? Think about it. Simple knife base. Is this performing good? Because if you see here, there are very few values here. There are very few values here. Very few values here. It is performing fairly good. In fact, very good. Okay, in fact, very good. Then we will create our classification report, same report. So precision, recall, F1 score, and support. So we'll create all of this. And then we'll try to find out some recommendations here. You'll have to write your recommendations. Then we'll create a functionalized code for different models. Okay, functionalized code for different models. In that, we will just create a simple model which will accept my model name. My model name can be random forest, it can be k means, k nearest neighbors, or it can be, what was the first one? The first one that you had to test was decision tree. Okay, so you can also use decision tree there. So we'll create a model training. In first case, we are doing the fitting, basically training. Then we are making predictions, and then finally using the predict prob, we are finding the probabilities of my predictions, and I'm returning my predictions and prediction probabilities. Then here I'm going to pass my object, my y pred and my pred probability predictions and object. Here I will train my test data and calculate the accuracy. Then I'll calculate my ROC AUC score, and then finally a precision recall and F1 score. Okay. Then we'll try with the same thing using the same code, this functionalized code on multiple classifiers. So the first one was decision tree classifier. I will provide this decision tree classifier and I'll pass this here. I will train the model and finally I will evaluate the model. The train accuracy I get is 1, which is very high, but the test accuracy is very low, 0.86. ROC score is also 0.91, which is fairly high. Precision is high, recall is also high, F1 score is also high. Nearest neighbors mein, we get test accuracy is 0.96, test accuracy is 0.934. This is also very good. ROC score is also 0.98, which is very good. Precision, recall, and F1 score, all of them are very high in this case. Next, we created random forest classifiers for the same. We use the same model, right? Model train. This is the functionalized code here. Train accuracy comes out to be 1. Test accuracy comes out to be 0.97. And then finally, ROC AUC score comes out to be 0.998, and precision, recall, and F1, they're also high. So we trained 4 models. We trained naive base, we trained decision tree, we trained random forest, and we also trained k nearest neighbors. Out of these, we have their results. Can we compare their results to find out which model is performing the best? Yes or no? We can do that, right, Pranav? Right, Reshma? So according to our analysis, we obtained that knife base is performing good. Okay, knife base is performing the best since it is giving me a good train and test accuracy. Also, here I'm getting good train and test accuracy, but this is fishy, right? That my train accuracy is coming out to be one. Do you agree with me, Pranav and Reshma? I don't feel confident when it is perfect, right? When my train accuracy or my test accuracy, they are one or they're very, very high. I generally feel it's a kuch to gadbad hai. There is something fishy which I'm not aware about. Okay, so you can check here, and this is also giving me non-significant overfitting depending upon the values of accuracy, ROC, AUC score, F1 score, and precision recall. Okay, so you can check there. According to this, we obtained that knife base is performing best. But imagine in this case, there are multiple things we could have done. What are those things? First of all, here we used one of the vectorizer, TF, IDF, or count vectorizer. We could have used both of them and checked whether these four models are performing better on which type of embeddings. And now that you know about much more embedding techniques, right? You know glove, word to vec, and now you also know about transformers. You can also use those. Okay, just to identify which one is performing better. And can you perform the same test using transformer based classification techniques, some deep learning techniques? Tell me, Pranav, can you create a deep neural network for the same process of classification? Can you do that? Deep learning. Can you create a neural network for a classification process on this data? Yes or no? Pranav, can you create that? This is fairly easy, right? You can train a neural networks. We have used our original, right, classical ML techniques, random forest, nearest neighbors, decision tree, naive Bayes. We can also create a neural network. Don't you think we can also create a neural network of our own with some hidden layers, with some layers, some hidden layers, and some nodes? We can find out some hyperparameters. We can tune some hyperparameters. And can I get better results using neural networks? But generally, we go to neural networks if my classical ML techniques they are not performing well. Generally, well, these are easy to implement, right? Classical ML techniques are easy to implement and easy to understand. On the other case, neural networks they are difficult to interpret. They're difficult to explain as well. So in this case, you can try for neural networks just to understand, just to gain more understanding of how my model will perform if I create a neural networks. Okay, that's just for your understanding, your learning. But if you don't want to do this, it is okay. It is okay. Okay, because our classical ML algorithms are performing very well on this type of data set. But this is not compulsory. This may or may not happen every time. This may or may not happen every time. So you have to be sure, okay, if I'm using neural networks, my classical ML algorithms are not giving me good enough results. That's why I'm going ahead to create a deep neural network. But later on, you will be using neural networks most of the time. Most of the time. Now, do you know about this website Hugging Face? Yes or no? Right. So here, what I will do, here I will find out bird case uncased. This is a website where you can store your models, you can use these models, or you can find out, you can directly import these models directly. There are multiple implementations here. You have PyTorch here and TensorFlow here. Okay, TensorFlow and PyTorch. For the current business case NER, you can use directly this. And also some transformer based. Okay, if you want to use, you can do that. Now, how do you use this? Everything is written here. Okay, how do you import this? How do you import this data set? Sorry, this model, you just have to use transformers.pipeline, and in the pipeline, use model based uncased. Can you do the same process for the previous business case study? Flip it for a classification process. For a classification process. And instead of using, for example, here we used very simple techniques, right? TF, IDF, and bow. There is also one more which is known as continuous bag of words. You can use glove, you can use word to vec. Now these are traditional, right? These are traditional. We generally in these scenarios in today's times we don't use this. Right now we use transformer based embeddings. transformer based embeddings. So can you find out an interesting embedding on this website, Hugging Face, and use that model to convert your English language sentences into tokens, into embeddings? Can you do that? Yes or no? Can you do that? Why am I telling you this? Why am I telling you this? Because you'll be able to understand more. Okay, you will be able to put yourself in the shoe of a real data scientist. Okay, well, transformer based embeddings. So you can find out embeddings for images, for videos, for text. Currently, we're working on text. There are multiple here, multiple embeddings here. Let me, okay, transformer based text embeddings. You'll get so many models created by multiple people. Okay, currently we are doing very traditional methods of creating embeddings. There are multiple people who have created these models to make our embeddings better. Our goal is to make our embeddings better, right, Pranav? And don't worry, okay? Don't worry if your size of your vector is too high. Don't worry. These days, the technologies have improvised. If our vectors are very, very large, we have technologies to handle those. One of them is Pinecone. Okay, search about this, Pranav. Pinecone. This is a vector database for our embeddings. Okay, this can handle very, very large embeddings, very, very large embeddings. This helps me in search, my semantic search. Okay, my semantic search, generation, chatbots, and then there are some other applications as well: anomaly detection, fraud detection, bot threat, identity verification. It also helps in personalization, for example, recommendation, feed ranking. So you can try these. You can try these techniques. Two things. One is Hugging Face, and don't worry if you're thinking, "Acha, yaar, my embeddings has become too large. How will my system handle this?" Don't worry. Okay, we have techniques. We have techniques, and these are the different models that you can try and search for it. What are the better models? Okay, what are the better models that you can find out? Think about it, and uh, this is just a learning process. Okay, there is no right or wrong answer here. Try as many things as you can, so that in an interview, when you're going for an interview, you have an answer. "Acha, I have tried this, I have tried this, I have tried this. This one performed better because I read about it, that this is the reason why it is performing better." Okay, there is one more thing. For NER, there is a tool. Okay, LIT, language interpretability tool. Interpretability tool. This is a tool given to us by Google. Here you can find out. Okay, just think about this. This is the vector it creates for my text. Do you see this, Pranav, Reshma? Do you see this? Try to explore this tool. Try to explore this tool. Okay, I'll paste the link here. This is a very interesting tool. So here you can find out some interesting features here. Okay, and this is my textual data, and here it gives me the vector embeddings. So you will be able to visualize your embeddings. Right now, what you have seen, 0 1 0 1 0 1 0 1, right? All those values. But how do you visualize those things? How do you visualize those things? So you can use this tool, language learning interpretability tool. Okay, this is actually learning interpretability tool, and there are proper guides here. Okay, there is a setup guide here. How do you install this? And there are some tutorials as well. Okay, there is one more in TensorFlow. Whenever you want to see TensorFlow vector one second, embeddings, visualize. I don't remember. Embedding projectors. Have you seen this embedding projectors that using TCNE or PCA? How you can change these vector embeddings? So here we have taken word to vec 10K. We are labeling by word, editing by word, and then there is a color map. Let's change the color map. Okay. So this is going orange. Okay. We can change this. For example, if I give for TSNE, it will retrain the data and it will give me another distribution or another vector code. So I can see all of this. These are the tools that you are going to use very frequently in natural language processing. Okay. So if you see here, let's see how it has changed now. Okay, so this is changing. One second. Okay, this is representing. Do you see these three lines, Pranav? Do you see these three lines? These are my axis, right? These are my axis, and it is giving us some results here. So if you go here, you will observe these are the points that it is changing depending upon the TCNE or PCA. Or you can also use UMAP, or you can also create your custom. Okay. So if you see here, prone and modest, they're coming very, very close to each other, right? Then there is another word, versus and versus, determining contrasted. So you can check these vectors as well. This will help you in understanding, in visualizing how vectors they are represented in my space, in my 3D space. Okay. This is actually very interesting topic, and there is one more topic that I want you to go through, which is known as perplexity. Perplexity. Just go through this word, perplexity, in NLP. Do you remember I told you one thing today? Sigmoid focal cross entropy. Sigmoid focal cross entropy. So perplexity is here. Okay, perplexity. This is used to solve the problem of lower perplexity. Okay. So you just find out what perplexity is, and how do we solve this using this sigmoid focal cross entropy. Okay, you'll be able to really understand what is happening. What is happening? For that, you will need to read this paper. You'll have to read this paper. Okay, you'll have to read this paper. Very simple. This is very simple. If you read this, you'll be able to understand that it downweights the well classified examples and focuses on hard examples. That is the only thing. But if you want to go deep, one layer deep, and you want to understand that how it is doing, then you'll have to understand the mathematics behind it. Okay. If you want to do it, only then do it. It sometimes becomes very, very complicated. It sometimes becomes very, very complicated. But we have methods directly defined in my Keras and in my PyTorch and in other frameworks. You can directly use this. You can directly use this. Is this clear, Pranav and Reshma? What are the steps that you need to take going forward, or how you can improvise your current business case study or flip it? Since you have not solved this, I'm giving you much more hints. Okay, this is how you can also solve. This is how you can visualize the data. These are the tools that you can use on your day-to-day business. Right? Cool, cool. I hope this was helpful, Pranav, Reshma. Okay, we have Sanjay as well. So I hope this was useful. And there are some questions as well. Okay, for today's business case, there are some questions for as well. Defining problem statements, where can this modification be used? Explain the data format, ONL bio format. And then what are data annotations? Why do we need tokenization? What are the other models that you could have used for the same task? And after performing this early stopping, you have to prove, or you have to basically explain that whether early stopping is helping you in achieving better results on your training and testing dataset. And then finally, how does BERT model expect a pair of sentence to be processed? So this will be, you'll be able to answer this question on BERT after the last class, after your next class. What is BERT and how it is helping me? BERT is basically bidirectional encoding for representational transformers. Then why choose attention based models over recurrent based? I think this is very clear to you. Why? What is attention, right? We have already covered what is attention, how, where I need to focus in a particular sentence, where I need to focus. Okay. Then differentiate between birds and simple transformer. This question you will be able to answer after the next class, not as of now, but the next class. So are you finding this module very interesting, the total natural language processing? And are you finding the deeper level of understanding that, okay, how this is how people thought that they will solve the problem of text? Yeah. Pranav is saying more interesting now. Pranav, do you have any feedback? I can unmute you, we can talk about that. Any feedback that you would want to share with me? I'm currently leading the module, so you can freely share with me what are your thoughts about the module, the questions, scripts, basically the content that we have. And how are you feeling more confident in giving NLP interviews from now on? Because we are getting some requirements. Pranav, to be honest, we are getting some requirements, and we want you to be prepared for those uh, positions to be filled as NLP experts. And this is a very, very interesting field. I know this is a little bit boring in comparison to computer vision, because in computer vision we can visualize how my pictures are changing, what is the effect of my model, and how it is representing. And there is more visualization aspect to it, right? In natural language processing, it is more about text. It is more about text. But the world is moving towards chat GPT and helping people write content very, very quickly. Have you seen the multiple applications of chat GPT? There are so many companies that have just started, right? Many entrepreneurs, they have just started their business based only upon the chat GPT. You can go ahead and see so many threads on LinkedIn. There are so many companies that have recently, and all those companies are based upon chat GPT only. So imagine if you could do that. After this module, you can start your own company using the chat GPT, and you can create your own tools, your own services. That is a possibility. That is a possibility. Okay. So I'm encouraging you to actually think, okay, more about how to solve problems in text. What are the different tools at my disposal that I can use? What are the different techniques I need to learn? Or is there any tool that I can directly plug and play? And how do I deploy all of this on a proper environment on cloud or on-prem services? These are the questions that we are answering now, and you have to learn all of this. But a genuine feedback. I need. We have three people: Sanjay, Reshma, and Pranav. Do you feel that this module is actually helping you in your journey towards becoming a better or a great data scientist? Matlab, are you able to see the intricacies of small things and how important they are? Right, they're so important. Some of the models are directly plug and play, right? Some of the models, they are plug and play, but we have actually gone into the depth of what LSTM is. Ideally, in your real business cases, you won't require to remember much of what LSTM is, what are gates, what is RNN, what is GRU. You would need to directly create those models. But as a data scientist, it becomes very, very, very important for you to know the internal details of those models. Very important. Okay. And why they're important? Because whenever you are stuck somewhere, you need to understand, okay, this was the problem, this is the source of problem. If you don't have that deeper level of understanding, you won't be able to find bugs, you won't be able to find differences in the results that you obtain and what you would have expected. Okay. So I hope we are meeting your bar and we are meeting your expectations. And if you have any doubts, just feel free to reach out to me. My email ID is nikhil.sanghi, SANGHI, at scalar.com. Okay, if you have any issues at any point of time, you can contact me here. And if you are facing any issues in the current problem statement, you can also reach out to me. Okay. Chalo, great. Thank you for your time and for your patience that you have attended this lecture. I hope we will meet again for the review session of this. Okay. Chalo, great. Thank you. Thank you, Pranav. Thank you, Reshma. Thank you, Sanjay. Okay. Bye bye. Good night. Take care. Have a good day ahead. Have a good weekend ahead. Okay. Bye bye. Take care. Bye bye.